So this is our first workshop in R, Intro to Data Manipulation in R. For those of you who don't know, my name is Viren. I'm the Education Director here for BDAA. So let's get started. So the workshop overview, we're just going to go over, what data cleaning is and how it fits into the overall workflow briefly, and then get into some of the packages that are used for data manipulation in R, and then introduce the data set and, start coding. So this is just the big picture, but what we're focusing on today is the data cleaning aspect. So, the importance of that is because, raw data is very messy. Usually when we get that data from a database or other external source, it needs to be cleaned in order for our data visualizations to tell a good story and for our models to be accurate later on. So we're gonna investigate that. So what a package is, we talked about this last week if you were in the Python workshop, but a package is essentially a collection of useful classes and functions that are used for common tasks. So in data science, data visualization, data analysis, data manipulation, machine learning are all very common tasks that are used in data science. So there are packages that allow us to use for these different tasks. So in R, actually what we're going to be using is the tidyverse, and the tidyverse is really at the heart and soul of R programming languages for data science, and it's a collection of packages that's used for data science tasks in R. So within it, there are a multitude of different packages, such as for what we're using today is data manipulation, right? So the package we're going to be using is dplyr. There's a package called ggplot2 for data visualization. For reading data, there's readr. So the tidyverse really encapsulates a lot of these packages, which are very easy to use. So with that, we're going to go ahead and get right into it. So the first link here in the chat, you should see, is the data set that we're going to use. So if you click on this, right, the data set is the top Spotify songs from 2010 to 2019. So what we're going to do is you want to make sure you can download this and save it to your file system, because we're going to need that. So in the chat, when you get the link for the data set, you will come here and you'll click download and save that. And then the other link that's in the chat is the RStudioCloud notebook that we're going to use for our actual coding environment. So once you click that, you can take a few moments to download the necessary things. I think I don't think the dataset one is in there, so I'll go ahead and send that. There's the dataset. It's the second link, so you can click that, download it. And then what happens is if you click the RStudio link, for assuming you guys made an account, it's going to ask you to first log in with your Gmail. So log in with your account information, and it's going to ask you to join this space. So basically there's a workspace that's been created for you to access this project. Once you join it, you'll have a copy of the project in your workspace. So go ahead, take a few moments and do that. And just type in the chat when you guys are ready. So I'm going to go ahead and join the space here. So So right here, if you go to your, you'll see that you'll be in the BDAA Data Mastery workspace, and this will be the project right here, Intro to Data Manipulation in R. So all right, so once you do that now, and assuming you guys are at this point here, now we're going to just click on this now, start, and it's going to start loading your project now. And so just for a few moments while it's deploying, I'm just going to go over, what the whole RStudio editor looks like, and some settings you can tweak as well. Well, you should, if you have joined this, it'll ask you to join the space, George. So if you click on that link, actually, it should, I can resend it here, but that link should definitely ask you to join the BDAA Mastery, Data Mastery link. So yeah. So for those of you who are here now, this is the editor. So we want to actually pull up the code that we're going to work with. So here in your files, you'll see the intro to data manipulation with R Markdown. That's what the file name is. So go ahead and click on that. And you'll see here that we have these 4 panes here. So I'm going to kind of go over what those are real quick. So if you go to Tools and you click on Global Options, you'll see we have all these options here. So if you go to Pane Layout, it just explains, the different panes here. So on the left here, it's called your source on the top left. So this is where we actually write our R code. In the bottom left, this is the console. And so this is where you can also write some code. So you'll see we'll be making use of this later on. And then on the right is your environment. So this just shows all your variables that you've kept track of throughout your whole project. And in the bottom right here are your files and plots. So that's where you can see any graphs. So you can adjust how you want to lay this out. So what I like to do, and you can change this if you want, I like to have my console on the top right and my environment down here, just so I can have it on the right and left. So if you want to change that, you can. Otherwise, that's okay. And then you just click apply and we're good to go. So now we'll go ahead and start here. So this is just the environment. So this is your code chunk between the R tick marks here. So you can go ahead and run this with the green button. So if you run this, it runs your 5 + 5 is 10. But you can also run multiple commands in a code chunk here with, if you run this, it'll run both. But let's say you also wanted to, just run one line. So if we just wanted to run this 6 + 6, we go to this drop-down menu and do run selected lines, and it will just, run this line. Similarly, the console, you can do write stuff here too. So if I write 7 + 7, we can also code here as well. If you think that this is, gets pretty cluttered, if you wanted to clear the console, you go up here to this clear console, this broom icon, and it will clear that for you. So that's just the kind of how it works. So now we're going to get into installing the package for today. So to do that, in R, I go to the console here and we run this command install.packages, and we specify the package name as a string. So the package we're going to be loading is the tidyverse, which has all these packages we need. So to do this, go to the console on the right and do install dot packages and specify the tidyverse as a string. And it'll freeze for a little bit and it'll take some time. But to know that the console is actually running a process, if you see here that there's this red stop sign here. So basically what this means is that there's a process running in your console. And if you want to stop it, you just press this red stop sign. So we see here, it's just going to take a few moments to install the various packages we need. So this will take a few moments. But now we see here that the stop sign's gone and it's been downloaded. So once that happens, now we can access the various packages within it, which is dplyr and readr. So once you actually install the package, now we want to read it into the environment itself. So to do that, you use the library function and you specify the package name inside it, but you don't have to specify it as a string. It will you'll see that it auto completes it for you. So the two we want to load in are dplyr and readr. So to do that, we run library, and then if we do D, you see dplyr loads. So all those different package names that showed up here, those are all the ones that are in the tidyverse. So another one we want to load is readr for reading in the data. So now once you run this line, you see here that all the packages that we need are attached. So now once we have the necessary packages read in, we now want to read in our data. So the way we do this is with the read CSV function, which is from the readr package. And we assign this to our object, which is going to be our data. And this is the object we'll refer to and select from throughout the rest of the project. So to do this, we set a data object. So I'm just going to call it data. And in R to specify or assign objects, we do a less than sign and then a hyphen. That's the kind of like the equals sign in R. And so now we're going to read in our CSV and specify the file path as a string. And our file path here is this top 10 CSV. So you want to specify this exact file path as a string. So we'll go ahead and do top 10s .csv. And now once you do that, it's just going to take some time and it's going to read in our data set. So now we can see that these are all the various columns and now we're ready to go. So one of the first things I like to do is just, the glimpse function from the tidyverse is good for just taking a glimpse of your data to see what kinds of columns you may have. So to do that, we call the glimpse function and we pass in our data object that we just created. So if you run this, you see here that it returns all the columns here in our data set and the first few values. So we can see as well as their data type. So we can see that we have a lot of doubles here. So these are decimals in our data. We have some characters. So these are some your string-like data types. So that's a good way to do some initial exploration. And then we can also print out the whole data set as it is. So if we just run data, this just prints the data set as it is. And this gives it in a nice format here called the tibble, which is kind of like the data frame in R. And we can also click through this as well with this arrow key. So it's very interactive. You can go through and just investigate what kind of columns you have. You can go through your rows with the various pages. So we can see the kind of artists and songs that are in this data set. So now it's time to go ahead and do some exploration. So some of the columns here, just to clarify, that might seem kind of unclear. We have our beats per minute, or which is the tempo of the song. We have the energy, so that's specified by NRGE. That's energy, so that the higher values mean there's more energy in the song. DNCE is the danceability, so how easy it is to dance to the song. dB is the loudness, which is measured in decibels. Liveness is the probability that the song was a live recording, so higher value means that it was probably a live recording. VAL represents the valence, so that's basically the overall mood of the song. So higher values mean that the song was more joyful, lower values mean it was more depressing, more sad. The duration is by DUR, so that's just the time length of the song. Acousticness, that's just whether the song was acoustic or not. And then the speechiness is how much spoken word is in the song. So high level of speechiness, it means there's more words. Low speechiness means there's probably no words. It was just an instrumental. And then the popularity is just how popular the song was. So one thing I like to do is to just return the columns from our data set. So you can do this with the col names function and pass in the data set that we have. So to do this, we do col names and pass in the data argument here. So what this will do is it will return the columns in a neat format here, so you can see the various columns we have. And this is always, you'll see me use this function a lot later on when we want to just retrieve this information when we want to select columns. So again, this is getting pretty cluttered. So I'm going to go ahead and I'm going to clear the console here. So now let's get into how to select a column in R. So we can do this with treating this data that we have, DataFrame, as a massive array and indexing it with the $sign. So the way we do this is we refer to this data object and treat this $sign kind of like an index, and we can specify the column name after. So if we wanted to retrieve a column, we do data $sign column name. And now if we have a column name here, which may have some white space between it, the way we retrieve that column is that we specify backticks. We wrap the column name in backticks with which has white space, so it tells R that we want to retrieve that column. So let's do some practice. So let's return the title column from the data. So let's go data and then title, right? So when we do this, it will return the title column. So you see here, these are the various songs in our data set. You might recognize them. But yeah, we can also another thing about R cells is that we can kind of close the output. So with this X here, if we click on this, it closes the output. And so you don't have to go through that whole entire markdown cell. And now let's return the top genre column from our data. So since top genre is our space in it, we're going to have to wrap this in backticks. So if we go data, and then, it also auto completes it here for you, and click top genre, and we run this, we see here that top genre is in backticks because it has white space between it. And again, you see here, we can see the various genres in our data set. I'm going to close this here, but that's how we can, specify and select one column from our data set. So now to select columns with dplyr, selecting one column with the data dollar sign is great, but we want to work with subsets for data to do any sort of analysis we need to. So to select columns with dplyr, we can use the select function here. So what we do is we pass in the data as our initial argument, so the data we're going to select from, and then specify the column names after it in a row. So if we wanted to select one column name, we pass in the data as our first argument and then pick the specific column name. If we want to select more than one column name, same thing, pass in the data and then, the multiple column names that we want. So here I'm going to just get the names of my columns, right? And I'm going to now, let's select the year function or the year column from our data set. So to do that, we go select, pass in our data, and grab the year column as shown on the right. And now when we run this, we can see we just have the year column. Now, let's say we want to select the popularity column. Okay, that's simple. So same thing, select, pass in the data, and get the popularity column, which is shown as pop. So we do that. And now another cool thing about these R markdown cells is that we can run multiple commands, but we can flip through the various data frames here to see what kind of output we have. So this is the popularity column. And now let's select multiple columns. Let's select the title, the year, the popularity, and the top genre column. So to do so, we're going to do select, pass in our data, and then we're going to select the title, the year, the popularity column, and the top genre, which you want to make sure you wrap it in backticks because it is a it has a space between it, white space. So now if you run this, you see here we just created a subset of our data, and now we have the 4 columns that we wanted. And then another thing we can do is let's say that we want to select the title, artist, top genre, and year, right? Title, artist, top genre, and year. We can do this by specifying each column individually, but one cool shortcut that you can do in dplyr is if you have column names that are in a row, you can kind of create an interval between them. So you can specify this colon, which indicates that you want to return every column from the beginning to that second thing after the column name. So if we want to return the title, artist, top genre, and year, since they're in a row, we can do this. We can do select data, and then we call title, and then we do a colon. So that means we want to select everything from the title column up to the year. So this returns everything artist and top genre with it. So if we run that, we'll see we get the title, the artist, the top genre, and year. So you could have done the same thing by specifying them individually like so, but this is just a shortcut. Usually this only works if you have the columns in a row. So just make sure if you're going to use it, you use it in that scenario only. So again, I'm going to clear this output here. So that's how you select the data. And so now once you select the various columns that you want, you might want to inspect it for, the first few observations or the last few observations to get a sense of the variability, or you want to look at, various summary statistics of your column. So to return the first few observations and the last few observations, that's returning the head of your data and the tail of your data. So we can do this with the head function. Similarly, if we want to return the tail, we just call the tail function and pass in our data as the argument. So if you want to return the head of the data, we go head and then pass in the data object. Similarly here, if we want to get the tail, we call tail and pass in the data right there. And now we can see the first 6 observations in our data set and the last 6 observations. So, one thing which is cool about this is I like to see, okay, so our data spans from the year 2010 to 2019. So indeed, we have 9 years worth of data, and we can kind of look at, okay, what songs were popular from 2019, what songs were popular from 2010. So it's a nice function to have at your disposal. So once we kind of inspect initially what kind of variability there is, we would like to look at the distinct column values that we might have in a specific column. So usually I like to do this when we have column names which are categorical or only have a finite set of values. And you can do this with the distinct function in dplyr. So to do this, you might see this. This is a common pattern with a lot of these functions where we specify the data as the first object, as the first parameter, and then the specific column names after that. So this is the theme we're going to see throughout this whole project. So here, let's say I want to return the different years that are contained in our data, right? So if I can do distinct, and I pass in our data, and I go year, right? If I run this, you'll see here that we see all the various years in our data set. So we can see, okay, it's from 2010 to 2019. Let's say I want to return the various different genres in our data set, right? So to do this, we do distinct, pass in our data, and then our top genre column is what it's called, is top genre. And if we do that, we can see that we have, and you can even confirm this if you return the column names, and you can see top genre is the column name. So you can see here that we have 50 rows, so various different genres in our data set, and you can kind of flip through these. And there's a wide variety. Some of them I didn't even know existed. Bro step, I don't know what that is, but yeah, so that's one way to explore it. Let's say we want to return the different artist, right? So we do distinct data, pass an artist, right? We see different artists here. And if you flip through the very end, we can see the more recent artists, during 2019, and keep flipping. And as the years progress, we might see a common theme within different artists who might have been more popular, what years or whatnot. So now we can return, all together the various distinctions. So let's go a distinct, and we want to return the artist, genres, and years. So artist, genre, top genre, and year. So if we run that, we can see here that it's now in going from 2010 to 2019. You can flip through and explore it. So that's one way to look at the distinct columns in your data set and kind of see what values they take on. So once we do that initial inspection, we want to get into looking at summary statistics of our various numerical values. So we already explored categorical values. Let's explore our numerical values and see what kind of patterns there are. So, R has a lot of these common functions, mean, median, maximum, minimum. You guys are probably familiar with these, and these functions all, same thing, except here, if you want to get it for a specific column name, you have to use that $sign operator like we saw earlier to extract the specific column name, mean, median, min, max, pretty self-explanatory. So let's return the average beats per minute for a given song. So if you remember, that's going to be the BPN column here. So let's go mean, and let's go data, and let's index into that BPM column. So let's do that. Let's return the median danceability. Let's go median data. And in this case, it's called DNCE. So let's do that. I'll return the least popular song. So let's return the minimum data and then pop, right? And then the longest song. So we want to get the max duration. So we go max data duration. So if we now run this, we can see we have computed the various different summary statistics for that specific column. So, things that, how this is helpful is we can see here that we found a song in our data set with 0 popularity. So this could be something that could raise some red flags to investigate if you're curious to, what songs did result in a popularity of 0. And, we'll see some of those verbs later on in other workshops. But yeah, that's how you can compute them for individual columns. But let's say you want to return summary statistics of all columns in your data set. So you can use the summary function to do that, and that will return the summary statistics of all your columns. So if you run summary and pass in your data, too many M's. If you do that, you'll see here that it returns the various different summary statistics, and you can kind of look through this and see, what sticks out to you. So, we can see the average BPM is around 119 beats per minute. What the popularity of some songs. So some songs had a popularity of around 99, so pretty popular, and kind of just get a sense of the behavior of the various songs in your data set or the columns in your data set. So a really nice function to have. So again, I'm going to clear this console here. So you can also do summarize statistics with dplyr with this summarize function, except you can get more control and select more columns. Just now we've selected summary statistics for just one column or the whole data frame as itself. But let's say we want to get summarized statistics for specific columns. So to do that, we call the summarize function with an S. We pass in our data as the object and then specify the various metrics we want to calculate from our column. So the mean of the column name, so we can set the mean, so mean is equal to mean column name, or we can get multiple metrics. So we can do mean column name and the median column name and specify that itself. So let's go ahead and do that. So I'm going to get the column names from my data set, and then let's get the average energy, the valence, and the duration. So if we go here and we do, let's say the data, and then let's get the, so one thing, if I do mean energy, right, NRG, and mean valence and mean duration, right? If you do not specify these, this like initial name here, the code still runs, but the columns are not that interpretable. And so if you wanted to, make the columns more interpretable, you would want to specify kind of like a name for the column beforehand and set it equal to the metric. So here you can see we just called it mean energy, mean value. So nothing was assigned. So this is what we got. But if we wanted to specify the names, we could do so by just setting it equal to the given name. So let's say we wanted to call this mean energy, right? And we go mean energy. So same thing. Let's go mean valence and get the valence, and then the mean dur, and we go mean duration, right? And if we run this now, you'll see that we got the same exact metrics, except the columns are a little bit more interpretable. And what you can also do is if you wanted to have white space between your column names, you just wrap that in backticks. So let's say we want to get the maximum popularity and maximum danceability and maximum tempo. So to do that, we would go summarize, again, pass in your data. Let's say we wanted to call it max popularity. So if we wanted white space, you'd again put the backticks and then go max pop, and then set that equal to the maximum popularity. So now we've specified that we want this as white space, so we wrap it in backticks, and then get the max danceability, and then we pass in the danceability column for the maximum, and then get the maximum tempo. So we can do max temp, and do that same thing where we pass in the beats per minute. So now when we run this, we can see that now this is even more interpretable. Whenever you want to get something with white space, rapid and backticks, and now we can see, okay, maximum popularity from our data set. This is the summary statistics. So 99, maximum danceability, 97, and the maximum tempo, or the song with the highest tempo was 206 beats per minute. So this is a nice function from dplyr that you can use to get summary statistics on specific columns from your data set and or name them accordingly. So this is also a nice function to have. So that's that. And then one thing you could also do is check out the relationship between any sort of columns in your data set with the core function. So this will return the correlation, R correlation coefficient between two specific columns. Again, -1 indicating a strong negative relationship, and 1 indicating a strong positive relationship, and 0 indicating no real relationship. So let's check out the relationship between BPM and danceability. Again, you want to index into the data frame with that $ operator and get the specific column name. Since you're checking correlation, you want to make sure that both of those arguments are numeric values. So let's go data, BPM, and data DNC. So let's do that. And then let's get the relationship between energy and valence. So if we do core data energy and data valence. And then let's get the relationship between the loudness and the popularity. So dB, and the popularity. Right, so like that, okay? And and we run this now and we get our correlation coefficients for the various different columns. So we can see here, there's not really much of a relationship between the beats per minute and the danceability of the song. There is a mediocre positive relationship between energy and valence, but nothing really strong there. And then same with between the loudness and popularity, there's not much of a correlation there. It's pretty close to 0. So this is a nice function to have if you're doing any sort of regression task and you want to do some initial exploration of various different features. So yeah, that's for your summary statistics and correlation. But thus far we've been dealing with the column names in our data set as they are, and they haven't been that interpretable, right? Like DNCE, NRGE, these aren't really things that would, I had to even look this up. So a nice thing that dplyr provides for us is the rename function, and this allows us to rename any columns in our data set to transform it and make it more interpretable later on. So when you're making any sort of visualizations, you don't want the NRGY column, to be in your visualization because no one will know what that means. So to rename various columns, you want to set it to your original data object because you're going to be making a change on the data set. And so you want to make sure that those changes stay intact. So to do that, you set it equal to your data object or whichever data object you want, a new one. And then you can rename it by passing in that data and specifying the new column name you want for that column, and then set it equal to the old column name. And then if you want to rename multiple columns, you do the same thing, except you have a comma after each pair of column and old column name that you want to rename. So let's go ahead and rename the energy column to energy. So since I want these columns want the change to happen to our data, we're going to set it to our data frame because this rename function is going to return a new data set with this renamed column. So let's set it back equal to the data, and let's call rename, pass in the data that we're going to rename, and set the new column, okay, energy, and assign that to our old column name, which is just energy. So now when we run this function, we'll see here that if we call call names function and we pass in call names, we pass in our data, our energy column here has changed from energy to energy. So this is why we want to set it back to our original data frame, so those changes occur. So now let's rename the dir to duration and veil to valence. So to do that, let's set it back equal to the data function, rename it, enter in our data that we want to rename, and let's set duration as the new column name equal to the old column name, which is dir, and valence, which is the new column name that we're renaming, and val, which was our old column name. So we have now renamed the dir column to duration and veil to valence. And now this is where we want to run the individual line. So if we highlight this and we run the selected lines, we can see that our data has indeed changed. So now our veil column is now valence. So now let's rename the acoustic to acoustic, and then the speechiness and the danceability and the loudness column like so. So again, set that to your original data object, rename it, pass in that data that you want to rename. Let's set the acoustic as the new column name, and the old column name was acoust, speech, and the old one was SPCH. And then danceability as the new column name to replace DNCE, and loudness to replace DB. Yeah, and so now you see last time I just highlighted this one thing. So we're going to do that again here, because if we try and run this as it is, we're going to get an error because it says can't rename columns that don't exist. And that makes sense, because if we try and run this process again, we've already changed the energy column, right? NRGE isn't a column to rename. So that's why we want to run this individual line with the updated data. So if we run this line now, and we pass in the data function to column names, we can see that our changes have taken place here. So this is a nice function to have to rename any sort of columns that might look weird, and be able to update our data set for further use. So let's go ahead and continue here. So after renaming your columns, you might want to answer some pretty interesting questions by arranging the various values in a specific way and sort them. So you don't have to write your own sorting algorithms. You have a nice arrange function to do that for you in dplyr. And to do that, you pass in, like always, like we've seen, is we pass in our data and the column name that you want to arrange. Similarly, let's say you want your, by default, this arrange function is going to return it in ascending order. But if you want the column names in descending order, then you wrap that intended column name you want to sort and pass in and wrap it in the DESC function, which stands for descending. So let's arrange the data by the year in ascending order. So to do that, we pass in the data and we do year. So when we run this, we see here that, if let's say we want to ask the question, what were, the songs from 2010? Well, we can see the first few here, and it's arranged by 2010, so in that ascending order. But let's say we want to see, okay, what were some of the more recent 2019 songs? We don't want to flip all the way to, 61, row 6, page 61 to see that. So to do that, we can pass in the arrange function, specify the data object, and pass in the year column into the descending, into the DES year descending function. So now we've arranged it in descending order, and we can see here that our years start from 2019 instead of 2010. So you can see some of the more recent songs are, Maroon 5. So I don't really know some of these songs, but yeah, that's the arrange function in dplyr. So yeah. Ultimately, when we use these verbs, it's great to do them individually, but we want to chain these verbs together and put it all together to, manipulate our data in one go. And to do this now, we are going to use some of the verbs we've learned here and, answer some interesting questions. So let's try and rename the BPM column to tempo. Let's select the title, artist, tempo, and loudness, and select those columns and save it to a subset. So we're taking a subset of our data and create a new object called data subset, okay? And then we're going to arrange that data subset by descending order of tempo. So let's first get the column names of our data set. Right. we're going to rename this BPM column to tempo. So let's go data, right? Remember to set it back to the original object. Rename, pass in the data, and rename the BPM to just tempo, and set that old column equal to that new column. So we've done that. We've renamed the column. Now let's select the various different columns we want. So let's subset it. Let's set it equal to a new object called data subset. Okay. And now we're going to select from that original data, the various columns that we want. So use that select function, pass in this data here. So data, and let's get the title, the artist, the tempo, and the loudness. Okay. And now if we run this, we see here that if we run the col names of our data subset, right, we have the 4 columns here in our environment. So now let's do the last thing, and let's arrange it by descending order of tempo. So let's go, arrange, and let's go data subset, and pass in our descending function. So wrap the tempo column with the DESC or descending function, and let's see what kind of output we get here. So highlight that and run selected lines, and we see here that we can now see the various different, in descending order, what the loudest or the most up-tempo songs in our data set were, in which in this case, it's a song by Rihanna. So, this was, this was pretty easy. We could, use these subset and set new objects, but this seems like quite a bit of code for just a simple operation. There has to be a way we can, we don't have to, what if we have more complex things we want to do? We certainly, this code could be even longer. So, in R, there's a way to simplify this with, what's called the pipe operator. And this is really at the heart and soul of R, which is a functional programming language. And what the pipe operator does is that it allows you to simplify the specific, the way you can chain the various verbs together. So just now we tried to chain the various different verbs, the rename, the arrange, the select, but we had to do this in 3 lines of code. What this pipe operator does, it allows you to do all of that in 1 line of code by specifying this as kind of like a way to specify the input. So here's an example to make it, to get this to sink in. So here, let's say we have the 16, right? We want to take the square root of 16. So, normally what we could do is we could, call the square root function, pass 16 as the input parameter, right? This would give you 4. This is how it should how you could do it. But what you could do also with the pipe operator is specify your input before the pipe operator. So we say that 16 is going to be our input. Write this pipe operator to say, okay, we're going to take 16 and we're going to pipe it into another function after it. So, and the function after it is the square root function. So we're telling it same thing, same line of code. We take 16 as our input, feed it into our square root function with the pipe operator. Similarly, if we want to take 4 factorial, right, we could, use the factorial function, pass in 4. Another way we could do it is say, okay, 4 is our input, pipe it into the factorial function. So we say this is an input, and this is what the function will take in. This is the function that our input will go into. And you can see that it kind of has that like arrow like shape, kind of like an arrow function for those of you who do JavaScript. And then you can also, chain these multiple pipe operators to specify other functions. So let's say we want to first take the square root of 16, then pass it into the factorial function instead of just doing 2 lines like this. Well, in that case, we can say, okay, 16 is our initial input. We're going to pass this into our square root function. Now, square root of 16 is going to be our next input for the factorial function. So we've now called square root of 16 here after passing this here, and now square root of 16 will be our input into the factorial function. And again, same thing here. That's what we have here, right? We have square root of 16 as our input to the factorial function. So this pipe operator allows us to chain multiple inputs or multiple function calls together in one line of code. And it's very helpful when you have a lot of various different data processes you want to run. So let's do some basic math here to kind of help get this concept to sync. So let's return the square root of 25 with the dplyr pipe operator, right? So we're going to use a square root function, right? And we're going to use the 25 as our initial input. So what we do is we do 25, and then to do the pipe operator, it's the percent symbol, the greater than sign, and then another percent symbol. So you can see here that it has kind of highlighted in gray now. So R knows that we're using the pipe operator. And we're going to pass this in to the square root function, right? Now let's run this, right? We get 5. So, we pass 25 into the square root function. Similarly, let's return 5 factorial. So 5 is our input. Factorial is the function which will take 5 as the input. So let's do this. So 5. And now pipe it as the input into the factorial function. All right, let's run that. Okay, 120, right? If we did factorial 5, we'd get the same answer here, right? 120. Now let's return 5 factorial. First, let's take the square root of 25, and then take that result and pass it into the factorial function. So 25 is going to be our initial input, right? We're going to take the square root of it first. So let's pipe that into the square root function. And now the square root of 25 is the input to our factorial function. So now let's take that square root of 25 and pipe that into the factorial function, right? And now we have 120. Now we have chained multiple functions together to get our desired answer. So now let's try and use this on our data set with the dplyr verbs to answer some interesting questions and really make use of this powerful operation and this powerful So let's say we want to chain multiple different verbs together, right? So the way we do this in this case, our initial input will always be our data. So we saw 2 cells above. What we did was we had our data object, we renamed the column, then we subsetted it with the select function, and then we arranged that data subset, right? This is what we just did in 3 lines of code. But if we did it with the pipe operator, we use this data as our input into the rename function, then we rename the data set, that specific column. Now that data, which is renamed, is now piped into the next column, into the next function, which is the select function. Now we select the various columns. So now we avoided creating that data subset object. So now we have selected the columns from our renamed data set. Now we can pass that subsetted data set into the arrange function, all in one line of code, and we'll get the same output as we did here. So let's just do some practice here. So let's select the title. Let's select the title, artist, year, tempo, energy, dance, and loudness columns, and then take those columns and summarize it by getting the average energy, median tempo, maximum dance, and minimum loudness. So let's get the column names from our data set. And let's, now our data is going to be what we're going to be doing these operations to, right? So let's do data, and let's pipe that in to first now select the various columns. So select. And now here, you don't have to specify data as your initial input. Why? Because we've already specified it here before the pipe operator as the input. So now all we have to do is say what columns we want. So we get the title, the artist, the year, the tempo, the energy, right? The dance, and the loudness. Okay. And now we want to summarize it, right, by getting the average energy. So let's call it, I'm going to wrap it in backticks, but you can name it whatever you want. Let's do average energy, and let's do mean energy. Let's do, in this case, I'll just do this to show various column names. Median tempo. So do that, and then median, and pass in the tempo column. Let's get the maximum dance. dance ability, and let's pass in the dance ability column right here. And then let's get the minimum loudness. So min loudness, and let's pass in that loudness column. So now when we run this, we see dance doesn't exist. What did I do here? Data select. Oh, I forgot to select. I spelled it wrong. So select the dance ability column. That's because I just didn't write it correctly. But now when we run this, you first want to make sure you select all the right columns. So now when we run this, we see that we just did all those operations just with the pipe operator, and we got the summary statistics that we wanted, right? Now let's keep going. Let's rename the population column to popularity. Let's select the popularity, the title, the artist, and the top genre columns, and let's arrange by descending order of popularity, right? So let's again pass in the data as our input. Let's rename it, and let's call it popularity, right? And the initial column is called pop. And then we pass that into the select function. And now let's select the title, or let's select the popularity, right? You can do it in any order, but since we just renamed it, let's select the popularity column, select the title column, the artist, and the top genre column. And then let's arrange that by descending order of popularity. So now when we run this, we'll see here that we now get the exact thing we wanted. We get our popularity, our title, our artist, and our top genre all in one line of code, right? It's the beauty of the pipe operator. Now keep in mind, now we didn't save this to another object. So this rename function only takes place in this line of code. So if we do the the data call, right? We didn't actually rename the popularity column itself because we didn't assign this to any object. So if you try and use this data set later on and you actually want to permanently rename the popularity column, you'd have to set this to a specific object to make sure those changes are intact. But in this case, let's go ahead and let's rename the top genre to genre. Let's select the artist title, all these different columns, and arrange by descending order of valence. And you know what? I didn't say this here, but let's set this equal to a object called data subset, like last time. So let's go data subset, right? And we're going to pass in the data function as the pass in the data as our input to the rename column. Let's call this genre, and let's rename the top genre column. Let's now pass that into the select function, and let's select the artist, title, acoustic, speech, pop, not popularity, valence, danceability, and genre, since we just renamed it. And then let's pipe that into the arrange function and do descending order of valence. So now when we run this, we'll see here that it hasn't printed anything because we've just saved it to an object, but let's again write that, run that piece of code. And now when we run it, we'll see here that we got our 8 columns that we wanted. We were able to rename that the column from top genre to genre, and rearranged by the descending valence. So, we just asked the question, what was the happiest song in our data set, right? So in just one line of code, we were able to answer that question. And it turns out our most happiest song is some Austin Mahomes song with a valence of 98. We could even go further into this and say, okay, what were the different genres which were associated with that? So that's a good way of using these verbs. So now let's answer one last question, right? This time I phrased it a bit differently. I said, what song has the highest amount of danceability? Find the artist, the title, and the genre. So, we know that we want to get the artist, the title, and the genre, and we want to investigate the highest amount of danceability. So we may want to select those 4 columns and then arrange them in such a way that we see the highest amount of danceability. So you can go ahead and try this. I'm also going to do it with you guys. So if you can go ahead and try this as well. But I'm going to use since all these columns are in the data subset DataFrame, I'm just going to use the data subset. So I'm going to go data subset, right? And you know what, just to show you guys, since I have a subset made, I'm going to just pass that in there. And we're going to get the danceability, right? So select the danceability, the artist, the title, and the genre, right? And now we want to find the highest amount of danceability. So we're going to arrange in descending order. So let's go arrange by descending order of danceability. Okay, so we're just able to answer this question all in one line of code. I know I say that a lot, but it's just crazy how this dplyr function makes our life easier. So we can see here that by our highest danceability, which means the most tendency to dance to it or easiest to dance to, I know the song is by Selena Gomez, Cardi B, Nicki Minaj are the top 3, and the songs are as listed here. So this was the first intro to R workshop. I hope you guys learned a lot and were able to dip your toes into the tidyverse. We're definitely going to be covering many more packages in the tidyverse through subsequent workshops, and as well as cover more dplyr. So yeah, I hope you guys enjoyed and really learned something today, and definitely, you know, practice this in your own projects if you ever have to do any sort of data analysis. So yeah, that was intro to data manipulation in R. If you guys have any questions, feel free to send me a message on Slack. Otherwise, yeah, have a good rest of your evening.